Hello everyone, and welcome back to a new video in our bridge series, in which we are going to continue our work on the modeling, analysis and design of a two-span pre-stressed beam deck bridge. In this video we are going to try to define our beams as a precursor to the definition of our entire bridge. So, well, of course, if you are new to this video series, please notice that this is a quick series I will be doing on a simplified bridge before I continue doing a full-scale analysis on the box girder, just to test the waters with Autodesk Structural Bridge Design and for you to get some insights on how the software and how the various systems inside the software work. So, well, let's start defining our beams, and with that being said, sit back, relax, and enjoy the show. Alright, so in the last video we have defined our materials. I'll be linking the last video on the top right, and now we're going to continue designing our beams and defining our beams. So I will go to the design beam. Now you can make a design section, but since I'm going to use ready-made beams, I will go to the design beams directly. Now of course, this is obviously empty because I have not defined anything. And let me remind you what we are doing. We are doing this, and in this system we have a span 1 and span 2, and inside span 1 we have inner beams, we have external beams on the north side, and external beams on the south side. Similarly, we have an internal beam on the center, and an external beam on the north side, and an external beam on the south side. So we should define all those beams. Basically, you can see this is span number 1, that's span number 2, those are the internal beams, and those are the two external beams. We need to define every single one of those as a precursor of defining our structure. So okay, let's start with the internal beam of span number 1. Now let me remind you that span number 1 has the following system. You have an internal beam here. So the internal beam is consisted of a pre-stressed precast beam and a deck slab on top of it, and the spacing from beam to beam. This is an internal beam, so I have to do one internal, one external. Also, notice that there is stages. So in the software, when I want to define, I need to tell the software that, hey, this part of the beam is going to be in the first stage, basically, the beam. Also, this part of the beam must be in the same stage. And then I need to tell him that the deck above the beam here, that's stage 1A, and that the deck above the middle beam, the 3 meters in the center, I know this is 6, but divided by 2, the other 3 meters here, that's stage 1B, okay? So we have the beam, we have stage 1A, stage 1B, and then finally, we have the second stage, which comprises the entire bridge, which is the finalization here. This is the side rail or the barrier, and of course, I don't need to stage them span by span because I will make the entire span with the same stage. So I need to keep this in mind when I define my sections, because I need to explain to the program each individual piece of the section is part of a design and analysis and implementation stage. So let's keep this into mind. I will repeat this because it's very important now. When I'm defining my beam sections, I need to define the beam sections such that the beam itself, this red line, is in the beam stage as well as this. And then I have to define my deck slab here to be in stage 1A, the deck slab here to be in stage 1B, and the entire barrier to be on stage 2. So with that being said, let's take a look how we can do this here. So I'll right click here and add me a new pre-tension pre-stressed beam. Now I should rename it, maybe. I cannot rename it, so okay, let's define it first and then rename it. So, okay, let's define it. The beam length is 21 meters. This is basically because the length of that thing is 21 meters. Let me see. It's not written here, by the way, but I think I mentioned this in the previous video. The center-to-center distance between the columns are 21 meters. And you can see that if you put 21 meters and just tab out, you can see that this support center-to-center is 21 meters. This is about beam to end face, one from the left and from the right. This can define an overhang, and I will show you what this means in a moment. This defines an overhang. If your beam extends beyond the support, then you should use it. In our case, it doesn't. Now we need to select our beam. I will select a Y-beam. Y-beam, this is a British code for a beam that I will show you how it looks, by the way. Now, if you click on Y-beam, let me cancel here. If you click on Y-beam, then the initial sizing table opens up. This is a recommendation. You can size differently, but the software basically tries to kind of enforce a recommendation for you. This is based on hundreds of tries and designs, and this is also found in different reports. What you see here is your span length, and what you see here is different Y sections that are adequate for the span length. Now notice something very important. This table changes with the spacing from center to center. If the spacing center to center of the beams is 1 meter, then you have a certain sizing. And if it's 2 meters, you have a bigger sizing. And you can see that suddenly the sizing jumps to Y7. But why? Because if you have a smaller center to center spacing between the beams, then the beam is less loaded. But if you have a bigger center to center beam spacing, then the beam is heavier loaded and you need bigger sections. I will select the Y7 section because that's what the recommendation is. You could select Y8, but I will select Y7. If you click on OK, you can see the beam has been imported here. By the way, you can pan by pushing the mouse wheel. You can zoom in and zoom out by using the mouse wheel too. Okay, so let's continue now. Now I selected the Y beam. I told you that this is the overhang. For example, if you put 2 and press tab, you can see that suddenly you have an overhang of 2 meters, which affects the center-center spacing, because what you input here is not the span length, by the way, and this is very important to note. What you input here is the beam length, and you decide how much the span length is by adjusting the places where the supports are. Now, of course, I want to try. If I put -5, will it understand? Oh, that's odd. It did. I was thinking that maybe it should give me a warning. It didn't. Okay, enough fooling around. So 0, 0. It doesn't matter now. Let's continue. So I have my Y beam here. Now this is an interior beam. Remember, we are here now. I want you to keep always remembering what we are doing. We are now at the red line here. We are now defining our red line here, the internal beam of span number 1. That's an interior beam. Now for the beam, I would need to have not one uniform section, but actually 2 sections. Why? Now, don't get me wrong. The beam here, the orange beam, the internal beam here, the orange one, and the internal beam here, the red one, have an identical section, by the way. The section would look like this. You would have a Y beam, and you would have a slab on top of it. This would be the section here, and also would be the section here. So it seems that there is no reason for me to define 2 sections. But actually, there is. There is a reason to define 2 sections, because despite the fact that the section is identical, the section is 100% identical between this and this. Despite this fact, the stages are different. And that's the reason why I need to split my section into 2 sections. Because in section number 1, I will add my beam and call the slab stage 1A, but in section 2, I will add my beam and call the slab stage 1B. So that's the reason, because of the staging, meaning that you would have to split your sections based on the staging and on any change in the section itself. Okay, so now I will add me 2 sections here, and notice if you click 2, you can define 2. Like look, if you put 5 here, suddenly you have in the drop-down menu 5 sections. If you put 1, will it work? It doesn't work, of course, because 1 means constant. Like if you put uniform, this means 1. But varying means something more than 1. So 2, and you can see 2 sections. Okay? So now we need to define the 2 sections and define a lot of other things besides the 2 sections. So let me now select section number 1. Okay? When you select section number 1, it opens for you something called the pre-tension beam section definition. Now the first thing you see is the beam itself, which is a Y7 beam. And there are no offsets, of course. That's the material. And the precast age is 4 days. This means that the age of the beam at stress transfer is 4 days. And later, when we add something here, for example, a slab, the age will be 60 days. Let me show you. So this is the beam. I want to add a slab to it. So I click here and say in situ regular. In situ regular, because this PC means precast beam. It means that it is precast and will be basically winched into place or levitated into place, Wingardium Leviosa. But here in this case, the slab is not going to be basically craned into place, but it's going to be cast into place. Now here the dimension of the slab must be inputted. My center-to-center spacing was 2000. See, you need to keep an eye on this. When I selected Y7 back in the day, I chose the spacing to be 200 millimeters. Now I need to abide by this here. Now the deck thickness is 200. And yeah, if you click OK, then everything is fine. You can see that in situ regular, stage 1A, exactly as it's supposed to be. You could choose another stage, but for now I would call it stage 1A. And it seems that it has only 3 stages here, which is interesting. Now for the offsets, those are perfectly fine. Offset means you can move the slab. For example, if you click on offset here and say 500 and tab out, you can see the slab moves 500. But of course, a 0 means the slab is dead in the center of the centroid of this beam. You can see that this is the central y-axis. Of course, the z-axis is offset up. This has been automatically calculated. You could change it, for example, 1070, then it's inside the beam. Of course, it doesn't make any sense. So 1270 is the offset I want. Now, in situ levels, you can specify those. No need for that, by the way, but if you click, you can specify the top and bottom. Now, you don't need because you specify the thickness, right? The neutral axis, well, this is from the beam. Don't change it. This is from the definition of the beam. You can make it change if you want. Perimeter, this is for calculations of, I think, torsion. I don't remember exactly the equations, but in some equations, the perimeter becomes important. Now, if you click on that, you can specify it. You do not need to specify it because the program will calculate it for you. This is user inputs if you want. Now, I'm not going to do that. I'll just keep it like this. And then finally, if you click OK, it will tell you, no, it cannot work because you need to merge by stage number, meaning that you are going to basically hit the Enter key on the stages. Let me show you. If you click on OK, it tells you, no, please click here so that you kind of fix it. So if you click OK, what we have done so far is we have defined section 1, meaning if you go back and click on section 1, you can see the section. Also, something cute that happens here is that you can see one full section. You would think, but Recorder noob. First of all, I'm not Recorder noob, but Editor CE keeps calling me that. But Recorder guy, I thought you said 2 sections, but I see one full section. What gives? Well, you see one full section because I still haven't defined the section location, so wait for it. This will come into play in a moment. Before that, I want to continue defining my sections themselves because the section hasn't finished yet. I defined the concrete of the section, but I haven't defined anything with regard to the steel of the section, and I need to define that. Also, section 2 is missing, right? So I need to define section 2 also. So okay, section 1 has been done. Let me revise it very quickly. Section 1 has a precast beam and has an in situ of stage 1A because we said that this is stage 1A. Now for the other beam, section 2, when you go here and select section 2, you can see that it kind of duplicates what section 1 has. That's a good thing actually because it makes my life easier. However, there is a difference because suddenly the slab above the section is going to be stage 1B. So the only thing I would do here is I would click here, select stage 1B, and that's it. That's everything I want. I think I should merge. Oh, it works without merging. Let me check. And that's it. We defined our sections. Now, since I'm talking about the location, let me define the locations right away. In the locations, we said that, if you remember, there is 6 meters in the center, so 3 meters each side, meaning that section 1 is going to be from 0 to 18, not to 21. And section 2 is going to be from 18 to 21. Let me just add it here. There we go. Fantastic. So now suddenly you can see 2 pieces of sections, which kind of makes sense in my humble opinion. This is basically the section locations. I will just click OK now. So now we have 2 specific sections, and each section has its own location. Now what remains here is we're going to define our reinforcements because the tendons are already defined. If you click section 1, you can see those pluses. Those pluses are the locations of the tendons, and those are defined because you already know for the section where the tendons are. This comes from the standard sections of the Eurocode UK Annex. So I click OK now, and I will go to the reinforcement because the reinforcement is not defined. You can see it's empty, and you need reinforcement for the slab. So we need to define it for the slab. Notice you can move the section if you want. I'll keep it at 0 here, and we need to define our reinforcement. So how do I define it? If you click anything here, nothing works. So there is a plus button. Sometimes it's kind of strange how Autodesk Bridge Design works, but that's how it works, so I have to roll with it. The plus here inserts a bar. Now, I'm not going to insert one bar. I'm going to insert a lot of bars. Let me show you. So once again, what have we done? Let me remind you what have we done. We have defined our 2 sections. Yeah, we have defined our 2 sections. Let me hit OK first of all. So what we have done here, we have defined our 2 sections. If you go to beam definition here, we are on design beam. If you go to beam definition, we have defined our 2 sections. If you click section 1, you can see the definition of section 1. If you go to section 2, you can see the definition of section 2. And now we are here, and also we defined the section location. Now we are, let me cancel this. Now we are here defining the reinforcement. Fantastic. Now here I want to hit the plus button to start defining my reinforcement. Now you can take your mouse and haphazardly click everywhere, which defines reinforcements, by the way. They look stupid and don't make sense, but I guess if you click OK, oh, wait, it actually understands it, which is cool. I thought it will just accept it. So clicking haphazardly seems not to be working, so I'll clear that. This works perfectly if you want to add a certain bar at a certain location, but this is not what we want. Why is it adding bars haphazardly? Because the current addition system is draw bars, meaning if you click, it just draws a bar. So when you draw bars, you can basically, for example, select here 10 if you want, and just click one click and then move, and you can see that I'm holding 10 bars in my hand. This is pretty cool. You can also define a certain you can define a certain spacing, and well, you can define bars by drawing them. That's not what we want because it's not professional. What we want is we want to select a face and we want it to define the reinforcement. So the type of generation is not going to be draw bars, it's going to be reinforce face, meaning I have to click a certain face. Okay, now before I do everything, look, if you click on reinforce face and 10, when you push here and say OK, it will add 10 bars. Now, I'm not really a fan of adding 10 bars. I will just add a spacing, not a number of bars, because that's the more accurate way of doing things. So I clear this, and once again, I will reinforce a face, so I have to click a face. And then I'm going to ask it to have a spacing of 200 millimeters. And now you can select your reinforcement bar. I think 32 is a kind of an overkill. I will select 25. Now, when you have the cursor, you have to select a face. So if you click on the top side, it selects the face and asks you for the cover. It's 50 millimeters. I click OK, and perfectly done. The reinforcement is there. Fantastic. If you click OK, suddenly in the table, you have your 10 bars basically here. Now, you can modify the bars, by the way. You can modify the bars where they start and where they end. You can see a start and end. You can click here, I think, and modify, or you can just Control-A everything, and then click on this paper button, which makes edit reinforcement attribute. If you click on it, you can decide exactly what the diameter is if you want to change your mind, and you can define where the location of the bars is. I'm going to add the bar's location to be starting from 15. Why did I add it, and why do I want it to start at 15? It's kind of strange. Well, it's not really strange, because the entire bars are going to be connection bars between this and this. So that's why I wanted to add it 15. Kind of 3 meters on this side and 3 meters on this side. You could have the reinforcement fully on the entire bridge. I know that your error senses are tingling because the first question that you can ask, dear viewer, is immediately, what about shrinkage reinforcement? And you are right, but please notice that what we are talking about here is the main reinforcement, not just some sort of shrinkage or minimum reinforcement. So this is main reinforcement now, and we need it because we need to connect those two stages together. The shrinkage reinforcement is something we usually add at the end of the analysis. So I know you are right. You also need shrinkage reinforcement perpendicular, by the way, but that's not what we're talking about. We're talking about the main reinforcement. Fantastic. I think I've done everything right. Let me just double check. Control-A. Yeah, 15. OK. I'll click OK now and OK again. So now I define my section with reinforcement. If you click on beam definition and, for example, go to reinforcement again just to check, you can see that your reinforcement is defined and there is the bar, which connects basically the two stages together. Fantastic. I'll cancel this now, and I'll go, I think we finished everything. Tendons you don't need to define because it comes predefined, like those are the tendons. So I just cancel this. I will not change anything here. Okay, what else do we have? I think this ends the section definition for the first section, but we're not finished yet. Why? Because I'll just click OK now. I will rename this, first of all. So I'll click on the pretension prestressed and click rename and call this, I don't know, inner span 1, meaning that I am trying to define this to be the red line here, inner span 1, red and orange, by the way. So I click OK here. Now, before I duplicate and copy and paste, there are things I need to analyze here very quickly. I need to analyze the differential temperature. So I right-click here and select Analyze Beam, because you want to do some calculations on the beam. Now, when you click on Analyze Beam, you can see that there are all kinds of problems. The stresses are not correct. The calculated displacement might not be correct, which is totally fine. The stresses are not correct and nothing is working because we still haven't designed the beam. This is perfectly fine. But what we are doing now in the analysis is we want to prepare the temperature gradient, because gradients are part of the analysis. So we need to add the temperature gradients to the beam. So how do I do that? Well, if you click on Analyze For, we want to analyze for the differential temperate and the primary stress. We cannot analyze for transfer and beam erection and construction and shrinkage because we still haven't finished our beam. But for the differential temperature, we can do it because it depends on the section only, so we can at least do this. If you click on that, it opens for you a profile or a analysis here. Now the profile is based on the code. I think I have explained this in Ash Tool profile in the previous videos. I forgot which one, but you can see this in the bridge series. I think I've done this one day. However, we're not finished yet because we need to change something. What I'm talking about here is the type of deck is concrete beam. It's not a slab because we are assuming that it's a beam. I know that you can say, wait a minute, there is a beam and a slab here, so which is it? The more pronounced thing is going to be the beam because the slab is only a small part of the beam, so it's a concrete beam. Now, is the concrete beam surfaced? Yes, you can have unsurfaced, waterproofed, and surfaced beams. This changes the gradient you see here. The surfacing is going to be 0.075. I'm assuming 3-inch surfacing. It's 2 inches here, but I will assume 3 inches. Now, it depends on the drawings you have. Changing this changes something in the temperature. This is an analysis here. And if you click on OK, this would have inputted the entire temperature gradient, which will be used for the entire beam. Fantastic. Something strange here is that there are some analysis here, for example, shear calculations. This is very odd. Like if you look, let's say you want to set the parameters for shear calculations. You know how you can set the parameters for shear calculations? You won't believe it. You have to click here and then click again. Like, what is this? Right? But this is how Autodesk Structural Bridge Design works. It's not really that user-friendly like Robot, but it's good at least. Now, I don't want to talk about shear calculations because once again, this is something for later. Because we don't have the loads, we did not put anything. What we can do is we can do some time-dependent calculations, basically shrinkage. Because for shrinkage, you need the section. And we have the section, so you can do it. If you click on that, you can set the shrinkage here. The only thing I want, now, I don't want to set everything here, by the way. For example, you can change anything you want here. I will just put here a 2, that the drying shrinkage starts at the second. You can change anything, by the way. And even the temperature and humidity affect the drying shrinkage. And you can change those. I just wanted to show you how you can do this. I'll just click OK here. I just changed for 2 days and I'll click OK. Of course, depending, this is very important, by the way, the ambient relative humidity and the ambient temperature depends on 1, the location, and 2, the season. So if you are in Canada, for example, you might have different ambient relative humidity, and I'm pretty sure you would have temperatures in the negative if you are in the winter, and maybe in the 10s if you are in the summer. Okay, joking aside, I'll click OK here. And yeah, I think we have done inputted our analysis parameters here. I just click OK now. I think we're finished, so I click OK here, and this ends the definition of the beam. So it does. We finished our beam. Now I need to make another beam. I need to make this beam, which is the one in the, I don't know what the colors are, in the dark red, this one. So you think, oh my God, I have to do the entire thing again. Well, relax. No, you don't have to do the entire thing again. You can just right click on the inner span and call it to copy. I'm going to make a copy here. So it's a carbon copy now. I right click here, rename it, and call it inner span 2. Now you think, wait a minute, it doesn't work. Why? Because look, for the inner span 1, this stage is on the right side, and for the inner span 2, this stage is on the left side. But if you click and check out what I've done, for the inner span 1, this stage is on the right side, that's good. But for the inner span 2, this stage is still on the right side, should be on the left side. Well, that's easy. Right click and reverse. That's it. That's everything you have to do. Fantastic. Now we have done our interior beams. Let's do our exterior beam. So I'll go here to inner span, right click, and I'm gonna be faster now because I think I've explained most of the things I want to explain. So I click here and basically copy it again. And this time I right click here and call it, I don't know, outer span or outer north span 1. I call it north because there is also south. Okay, so this is gonna be a long video, I can see. I click on the north and go to beam definition. And by the way, something strange, if you click on north, nothing opens here. You have to click on the beam definition to get the beam definition. It's kind of strange. I was expecting if you click on north, you just get the beam definition directly, but no, you will not get it. You have to click on beam definition. You have to be very specific here. Okay, so what do we have here? This is the external slab. I'm talking about this, by the way, just that we're on the same page. I am talking about the beam here on the edge. And by the way, let me tell you the beams we have here. For the carriageway, I will have a beam here and a, let me see, it's 8 meters, right? Let me just check. This is 8 meters, so 1 meter here and 1 meter here, 6 remains. So 2 meter spacing, meaning 1 and 1. Those are my beams, yes. Those are my inner beams. 1 here, 1 here, 1 here, and 1 here. And you can see the center to center spacing is 2 meters, and that's perfectly fine. For the edge beam, it's going to be different because I have 1.5 here. So it's going to be iffy. How can I do that? I think I will put me an edge beam here. Let me draw it in green. This is going to be my edge beam. And it's going to be maybe 1 meter from this side and half a meter here. Yeah, I think I will do that. So I'm thinking loud now. I'm thinking of making an edge beam like this. Now it looks like garbage. I know I'm not really the best of drawers. And this, let's say this is the centroid of the edge beam. I will have 1 meter on this side and half a meter on this side. That's my plan. Because like 1 meter on everywhere. Why 1 meter? It's not because I like to do 1 meter. No, it's because I want to keep a center to center spacing of 2. And because this takes 1 meter, I have to have 1 meter here. Okay, so let's implement this. Now, first of all, I want to suggest a YE, which means Y external. Remember, it's 200 center to center. It still suggests the YE7, so I click OK, which implements the YE7. I still have now, by the way, I have an exterior beam here, because it's the exterior beam, obviously. And yeah, I'll just follow up the same things, the same shenanigans. I click here and select section 1 and start defining. Okay, let's see. This is the external beam. Wait, what are we doing? Section 1? Okay, everything seems to be fine. No, this is changing. This here should be changed because it's not like, look, this is the centroid. It's not 1 meter on each side. At the moment, it's 1 meter and 1 meter on each side of the centroid. No, we said I want 1 meter on one side and 500 millimeters on the other side. Meaning that my slab is 1.5 meters because that's what you see here, 1.5, right? So I need to change that. Now, the crazy thing is there is no way of changing it. You have to, believe it or not, you have to click in situ and click it again just to be able to change it, which is, I don't know, interesting to say the least. So 1500 by 200, fantastic. If you click OK, it asks you to update section 2 because there are 2 sections. Yes, do please. So it updates the sections, but that's not what we want. Why? Because look, this is still center. We want it to be 1 meter on this side and 0.5 on this side. So I have to shift it 0.25 because at the moment it's 1.5, right? So it's 0.75 on the right side and 0.75 on the left side. So I have to shift it 250 millimeters. So I'll go here on the Y offset and click 250, enter. Of course, I want to modify for everything. So it shifted it. Now you can verify by moving your cursor. You can see here there are coordinates, and if you move, you can see it's at 1 meters, exactly as it's supposed to be. Fantastic. Now the new thing on the edge beam, we have a barrier. So I have to once again click here and add me another in situ concrete. This time the concrete is 200 by 500. That's the barrier. I click OK here. This abomination is here now. Now, before I do anything with the abomination, remember, that's the barrier. And we have agreed that the barrier is going to be in stage 2. So here, I will make sure it's in stage 2, and it is indeed. Fantastic. I have to move the barrier. I will move the barrier to be here. So I need to move it. Let me think. I need to move it. Let me see. I just try an error. Okay, so that negative 500 doesn't put it here. Okay, so negative 600 maybe. Okay, so far so good. Now I need to push it down a little bit. So instead of 1470, I put 127. Click 1270. Let's see. This is acceptable. Yes, I think this makes sense. I click merge by stage. Yes. And then I click OK. By the way, the merge stage means that he eliminates all the intersections, which is fine. I click OK now. And look, we have our barrier. Of course, we have our barrier only on... And we have something strange here. Wait, what's this? Oh, we have steel bars. Well, of course we have steel bars because we have shrinked our slab. Oh my, we need to change that. But before we change the steel bars, we still need to have a barrier on the other section. So I click on the section here, just double check everything. This is beam, this is 1B. Okay, everything is fine so far. I'll click on define again. Wait, what? Oh, sorry, I don't want a precast beam. I want a in-situ regular concrete. Once again, 200 by 500. And I think it was 600 was the offset. Yes, and 1270. Click first, 1270, enter. I think everything seems to be fine, right? I click OK. Yeah, I have now the second section. Now, still the problem was with the bars. So let's fix the bars. That's a lot of work, right? I click on define, I click on reinforcement and see what happens. Yeah, I can see 2 reinforcement outside here. Maybe 3, but I don't want to delete the third one because it's inside the barrier. Let me select those 2 things like this. And now, how do I delete this? Negative? Is it negative? Yeah, there we go, negative, it seems. Okay, and then okay again. And I think we are done. I think we have done it. Let's see. Inner, and outer. I'm missing something. Now, I know I'm missing the south one, but I'm missing something. What am I missing? Oh, yeah. I need to do this. Yeah, of course. I need to do span 2. Yeah. My bad. So how do I do this? Right-click here, copy. And I'll right-click here and change the name to outer, north, span 2, and of course I will reverse it because the central place is what is going to be cast later, so I will reverse here. There's one final thing that I will not do, but it's regarding the gradient and the barrier. It's because I have a barrier here. The temperature gradient kind of changes because the barrier is a further thickness on the beam, but I'll just leave it. I will not change the temperature barrier, the temperature gradient. We have defined in this video our design beams, and we successfully copied it, reversed it, understood different aspects of the design beam. So yeah, that's basically everything I wanted to talk about today in this video. I hope you enjoyed it. And before I finish, I want to give a Y-beam sized shout out to my dear channel members in the contributor level and the helper level, whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.